Welcome back for this third installation of my Learning Visual Basics series. Today we're going to go over creation and populating of variable arrays, string functions, looping, and conditional or if statements. First, let's review how to declare and define simple variables. To declare a variable, you start with the dim statement, means dimension or reserved memory. It's kind of a throwback to the olden days. Then the term that you want to create as a variable. In this case, I'm going to declare input value as a double. Doubles mean it's a floating point or decimal variable. If I want an integer, maybe I'm counting, something like that, I use the dim statement to create the variable, state what my variable should be, and then as integer. The last one that you're going to need for the sake of this course is dim the variable name and as string. Strings are used for storing text. So for the definitions, we'll come down here. Here's some examples. Input value equals 3.45. That's a valid VB statement. Output value equals 4. That is legitimate because output value was defined as an integer. And if I want to store text, as in the variable page title, I use double quotes and then whatever I want to store. In this case, I'm using my dog Gracie as the stored text. So, not too hard. Now we come to variable arrays. An array is nothing more than a named set of variables that we can access with one or more indices. Indices are nothing more than the position numbers. Conceptually, it's just like an old-fashioned mailbox. So I could call this mailbox my data, and this could be position 0, 1, 2, 3, 4, 5, 6, and write down the rows and columns. To declare a variable array, you use the dim statement, just like any other variable creation. You give it a name. In this case, I'm going to call it mailbox. Seems appropriate. The number of positions. Now remember, this gets a little tricky. You can always start at 0. So even though my mailbox in the example has 30 slots, I declare 29 because I have 0 and as double. Double is saying what I'm going to store in this set of variables called mailbox. If I want to store a value in box position 5, I just use the command mailbox position 4, because I'm going from 0, equals 3.45. So not too hard. But let's step up our game a little bit. Now I wanted you to consider a two-dimensional array. So we're going to have two indices, rows and columns. Imagine you do an experiment where you read 5 temperature sensors at a particular time and you repeat the data gathering 5 times, like this. You would be able to create some chart that looks kind of like this. You have a grid with rows and columns and all these little data values. Kind of looks like our mailbox from before. So we can set up our data to conveniently access each row and column using a 2D array. We're going to create the array by issuing the dim command again. I'm going to call the array measurements. And then we put the maximum number of rows and columns, always -1, because we can start at 0. And I have to tell it what kind of data I'm going to put in. In this case, I'm going to put in doubles. We fill the data array using the format measurements, row, comma, column equals whatever value we happen to want to put in there. So for example, if I want to fill this green position box, an actual legitimate definition might be measurements, measurements 3, 1, because I'm in the 4th row and the 2nd column equals 26.5. Remember, floating point numbers are for measuring, integers are for counting. You can get some really, really strange program results if you violate this. Text boxes and how to manipulate strings. We're going to talk about two types of text boxes, the rich text box and the plain text box. The rich text box is a lot like a modern word processor. It supports formatting, it supports embedded graphics, it's pretty high-end. However, the common text box, the simple text box, is a lot like the old green screen monitors where we just printed text to the screen. The way we send text to the screen, most commonly, is rich text box, the object name, dot append text, and then whatever text we'd like to send, generally followed by VBCRLF. So that stands for Visual Basic Carriage Return with Line Feed. The carriage return with line feed puts your cursor on a new line so you can begin adding new text without just infinitely going off to the right. The simple text box works just like the rich text box, other than formatting, if you choose multi-line properties set to true. We can use the text box as an input device. So if I decide I want to store the contents of the text box in a variable, this is how you do it. You simply say whatever variable, needs to be a string variable now, equals the object, in this case textbox1.text. When you're manipulating a text box, the following commands are pretty useful. So if I just want to clear the box and put some simple text in it, that is the command I just went over. In this case, I'm going to say put this literal, sending this text box, this text to the text box in the variable, and then I'm sending it to the text property of the object. You concatenate strings with a plus sign in VB. If I want to add to whatever's in the text box, I choose my object, in this case textbox1, and I append the text. In parentheses, I add whatever I want to send. If I want to clear the text box, I can say textbox1.clear, or just come down and send it a pair of double quotes. Either one will clear out the box. Now, if I want to manipulate strings, the following commands are useful. And you're probably wondering, when am I ever going to manipulate strings? Well, these are going to come in handy when we get to the Crosby machine controller. It uses formatted strings sent via USB between Visual Basic and the Arduino. So it needs to be able to look at substrings of the command. The first few characters are the command, and generally the last 4 characters are the data that's being transmitted or received. So this becomes pretty important. If I want to look at the number of characters in a string, we have a command for that. It's called the len command. So I pass the len command the variable that contains a string I want to look at, and it returns an integer, which is the length in the number of characters. If I send it to this example line, this command returns there are 8 characters in hi there. Okay, that could be useful. If I want to pick out a middle substring of characters, I can use the mid command. So the full command is actually strings.mid. You pass it whatever variable contains your text. You tell it, I want to start at position 4 and send me back 3 characters. In this case, the leftmost characters are high. Well, not really. There's a space in here that's not printed. So it did execute correctly. It's just a non-printed character. And if I actually run the code, here's what I get. I just copied and pasted this output window into the previous slides. Okay, so always remember, spaces count as characters. Now let's actually output something to those boxes. We're going to move on to looping. Now let's talk about looping. By far the most common looping in Visual Basic is the for next loop. The for next loop is a loop of choice when you know your start and end. So for example, if I want to output some values to a text box and I have a known start and end point, in this case I'm going to start at 1, I'm going to go to 5 in increments of 0.5. So this will execute through, it will send the value to the screen, print out a carriage return, and then go back up and just keep looping through this for next loop until a equals 5. When a equals 5, it will not loop anymore, it will drop out and end the subroutine. And this is what the output looks like. You can leave off the step modifier if you're going in increments of 1. So step is only necessary if you're going in something other than 1. Okay, you can also nest loops. Sometimes you may need a routine to repeat a certain number of times. So in this case, we have this B loop in the center that's going to repeat from a equals 1 to 5 in steps of 0.5. Looking at what's going on inside, we're appending the text in the text box to add new lines that output the value of A and B. And here's what you get. So B goes from 0 to 3. That loop ends. Then we increment A, and B counts from 0 to 3 again, and we increment A again. The do loop. The do loop is used when you're not certain when you're going to reach an end condition. Maybe you're doing some kind of FEA routine where you're looking for convergence, something like that. That would be a prime opportunity to use a do loop. For this example, we're going to use a very simple case. I've defined B as an integer, I've set it to 0, and we're just going to loop while B is less than 4. So it comes through, it prints the value of B to the screen, increments it, and loops back through. And it's not hard to imagine what comes out. You can also test for completion at the end. This example really just flips when you test for your condition. So in this case, same thing, define B as an integer, set it to 0. I go through my do loop and I test at the end. Now sometimes you may exit a loop. Maybe you're doing that find FEA algorithm and you realize that your solution is just not converging, or you're approaching a division by 0 problem. If you need to just stop iterating, the command is exit. And here's how you implement it. So I have a do loop, set up here. I'm outputting to the screen, incrementing b, but now I have an if statement. If b equals 2, then exit the do loop. So the code will immediately cease functioning and it will go to the line after the loop. That can be very useful to avoid a nasty crash. And the result is 0 and 1. If statements. The functionality of an if statement is really a pretty simple thing. What we're testing for is a true condition. So, for example, in this if statement, I want to know, is this expression in the parentheses true or false? If it's true, then I do the item specified between the if statement and the end if. So let's look at this little piece of code. I define a as a variable. I increment through, substituting initially a as 1, a as 1.5, a equals 2. I come down, I write it to the rich text box with a line feed. Then I come down to my if statement. And every time I say if a equals 3, then do what's in here. Well, each time I come through, it's going to be false with the exception of when a equals 3. Then this evaluates to true, and the commands in the if statement are executed. So what does this look like? Exactly what you'd expect. I count through, I display my values. When a equals 3, the computer writes out Wednesday is Prince Spaghetti Day, and then finishes the for loop. We can also add the else modifier. So in this case, I've got an if statement with an else. If the condition is true, the top items are executed. If the expression evaluates to false, then the bottom items are executed. When I run this code, first time through, not spaghetti day, not spaghetti day. Oh, a equals 3 though, so it says Wednesday is Prince Spaghetti Day. And then we continue to go through not spaghetti day. So that's how you get it to react to both true and false conditions. There are all kinds of modifiers you can add. Or excuse me, not modifiers, but logicals you can add. So you can add an and statement or an or statement. But it all comes down to the same thing. You're evaluating all of these expressions for true or false for the entire group. If it's true, does the stuff at the top. If it's false, you do the stuff at the bottom. Now sometimes you want to do a not. In this example, I would say if a is not 3, then do this. Otherwise, if the condition is still false, then do this one. So this gives a completely inverted output from the other code. That was a very fast example, and thank you for watching.